We've made it to lesson 23C. We're going to talk about volume for a rectangular solid, a cube, or a cylinder. And like always, I have videos linked in the description. If you've missed or skipped any of the previous ones, they can help you out if you become confused. And remember that you're going to be given a paper that's going to have formulas on it, math formulas on it, before the GED math test. So you won't have to memorize them, but you will need to know how to use them and identify them, okay? They might be labeled. Volume is the number of cubic units, cubes, needed to fill a three-dimensional space. A cubic unit has the same length, width, height on all of its sides. It could be a cubic inch, so if that's an inch this way, an inch this way, and an inch that way, that would be a cubic inch. Or if they were each a centimeter, that would be a cubic centimeter. If they were each 12 inches, a foot, that would be a cubic foot. Or if they were each a meter, that would be a cubic meter. All three measures, length, width, height, would be the same. And there's four sides and a top. So there's four sides going around, and then there's the top and the bottom, right? They would all be the same measure. And each of these surfaces is called a face. So a cube has 6 faces, the 4 going around it and the top and the bottom. So when we were doing length times width, that was a 2-dimensional plane. It was just length times width. When we do volume, we have length times width times height, and that's 3-dimensional. And to find the volume of a rectangular solid, we use the formula V equals LWH. You remember that when they're all next to each other, it means multiply. So it's volume equals length times width times height. Because we're using 3 measures, LWH, our volume will be in cubic measures with an exponent 3. So it'll be like inches cubed or centimeters cubed or feet cubed. So here we've got, it kind of looks like a stick of butter. The length is 10 inches, and the width is 2 inches, and the height is 2 inches. All we do is the length times the width times the height. So we can do 10 times 2 times 2. Well, 2 times 2 is 4, so that's like 10 times 4. So that's 40 inches with a little 3 exponent, or we can say 40, CU for cubic, IN for inches. What is the volume of a rectangular cardboard box with these measurements? If the length is 18 inches, the width is 12 inches, and the height is 8 inches, we just multiply them all together. 18 times 12 times 8. 12 times 8 is 96. We do 18 times 96 in our calculator and get 1,728, but it's inches cubed because we're doing volume, or cubic inches with the CUIN, see? And we know to put that inches as a label because the problem told us that it was in inches, okay? To find the volume of a cube, we know all the sides are the same measure, so we use the formula V equals S cubed, S to the 3rd power. What it's saying is, because this is the same measure as the top and the side, we can just do side times side times side. And the length is 3 inches, the width is 3 inches, the height is 3 inches, and 3 times 3 is 9, times 3 is 27, so it's 27 inches cubed, or 27 cubic inches. On a calculator, we could use that little x to the y power key. You would enter 3, and then hit that x to the y power key, and then a 3 again, and then the equal sign, and you'll get 27, and then know that it's inches cubed, see? Because we're doing 3 to the 3rd power, see? What is the volume of a box that is 2.5 feet on all sides? Well, it's giving us feet. We can use 2.5 for 2.5, so it's 2.5 to the 3rd power. We do 2.5 times 2.5 times 2.5, and we get 15.625 feet cubed, or to the 3rd power, which is the same thing as 15.625 cubic feet, okay? To find the volume of a cylinder, we use the formula V equals pi r squared h. Now, do you remember from the previous video, the area of a circle is the formula A for area equals pi r squared? Well, that was a flat circle. We add height to that, and we have a cylinder. So if we knew the area of this circle right here, all we'd have to do is multiply it by that 4, and we would have the volume. In this case, it only gives us the radius. So we're going to do pi 3.14, so now we have to use the approximate symbol, right? We have 3.14 times the r squared would be the 2 squared, because that's the radius, times the height 4. We do our multiplication, and we get 50.24 inches cubed, or 50.24 cubic inches. See? And it's approximate because we're using pi. So this was the equation for the volume of a cylinder. It says, which equation will find the volume in cubic centimeters of this container? So which one of these would find the volume in cubic centimeters of that container? Well, you can just match it. Pi is 3.14, so you know it's not the first two. The radius squared would be 5 squared, wouldn't it? Well, there it is there. And then times the height, 7. So it would be number 4. And the radius is 5 centimeters, so we use the 5 squared for the radius squared. 4 is the answer. Now, if we already know the area of one of its bases, we can use that area times the height and just be done with it. You have to look at the diagrams carefully because it might give you the area. Just read the question again if needed. So if it asked you which equation would find the volume, and it tells you the area of this base is 0.785 centimeters, you know that all you have to do is multiply that times the height, and you've got the volume, because it already did the work of the pi times the r squared for you, and it already found the area, it gave it to you, see? Now this formula solves for volume of a rectangular solid, and as I've said before, we can change it. We can switch it around to solve for a different letter. So we can solve it for height. We just take this formula and we divide both sides of the equation by the L and the W. That makes a giant 1 because it's got the same numerator and denominator, and that leaves the H behind. And now on this side we've got V divided by length and length times width. See? Now we're solving for H. We could also solve it for the length. If it wants to know the length, we just divide both sides of the equation by the width height WH, and now it becomes volume divided by width times height equals the length. We could even solve it for the width. We can divide both sides of the equation by the length and the height, so the W is left behind, and it'll become volume divided by length and height will equal the width. See? For the volume of a cylinder, we could solve it for the cylinder's height. So if we know what the radius is and we know what the volume is, but we don't know what the height is, we could solve it for height because we could divide both sides of this formula by pi r squared and make one giant 1 because the numerator and denominator are the same. So on this side of the equation, see, and the h gets left behind. On this side of the equation, we have volume divided by pi r squared will equal the height. And we can solve it for the cylinder's radius. Just remember that it's squared. We can divide both sides of the equation by pi and h. That'll leave the r behind. And we'll end up with volume divided by pi times the height will equal the radius squared. Okay? So just remember that's the radius squared. It's some number times some number. All right? And for volume, if we know that it's 3 units this way and 5 units this way, then we know the area of the base is length times width. It's 5 times 3. It's 15 square units. To find the volume, if it's 6 units high, then all we have to do is multiply that 15 by 6, and it's 90 square units. We know the volume. See? So if you know the area of a base, you can just multiply by the height and get the volume. If you know the area of a base, multiply that number by the height to get the volume, okay? So you should now be ready to do the skill focus on page 279, and our next video is going to be about pyramids and cones and the volume and base area for those, lesson 23D, and these are really good grade 6 videos that talk all about this. If you want to pass the test, my advice is click on the description and start watching those to get more in-depth and to get a review of what I just showed you, because sometimes it's boring to watch this video a second time. If you want to, that's fine, that's great. But if you want to see me say something else and not watch the exact same video, click on these and watch these. And the grade 7 one is good, and this one is going to be linked in the description. This was in the playlist. It tells you how to rearrange formulas if you still need it. And of course, the previous videos, 23A and B, about applying formulas for this lesson, okay? So, keep trying, and have a great day, and I'll see you next time. Bye.